In 1989, a medieval brick tower in the Italian city of Pavia suddenly fractured and collapsed into a massive cloud of dust. That sudden destruction sent a wave of panic 200 miles away to Pisa. By 1990, inspections revealed the Leaning Tower had reached a critical tilt of 5.5 degrees. The Italian government triggered immediate emergency protocols. They permanently closed the monument to the public and frantically hoisted the heavy bells out of the top chamber to shed every possible pound of extra weight. After standing for 8 centuries, the world's most famous architectural mistake had reached its structural limit and was on the verge of shattering. Millions of years before any bricks were laid, the nearby Arno River flowed directly beneath the modern build site. This cross-section shows the ancient riverbed layers, including a thick band of waterlogged silt just beneath the surface. When construction began in 1173, builders poured a shallow foundation on this unstable layer. Under the weight of 3 floors, one side immediately began sinking. A regional war broke out, halting construction for nearly 100 years. That century-long pause allowed the heavy stone to slowly compress and stabilize the soil. Without that delay, the incomplete structure would have likely collapsed under its own weight. When new architects took over, they tried to correct the severe lean by building the upper floors noticeably taller on the sinking south side. You can trace the structural workaround all the way up to the bell chamber, which requires 4 stairs to enter on one side, but 6 on the other, giving the entire tower a subtle curved shape. Centuries of masking the visual symptoms with masonry tricks ignored the true mechanical problem hidden underground. In 1834, an architect decided to dig a trench called a catino around the base to expose the buried original foundation. Excavating that dirt fatally disrupted the surrounding soil pressure, causing the masonry to suddenly lurch an additional 1/4 of a degree. A century later, Italian dictator Benito Mussolini viewed the leaning landmark as a national embarrassment. He ordered a brute force fix, directing crews to drill holes directly into the stone foundation and pump in 90 tons of heavy liquid concrete. Instead of anchoring the base, the immense weight of the concrete crushed the soft south side soil even deeper. The tilt rapidly accelerated, pushing past the 5-degree mark. Every attempt to force the tower straight using rigid materials and heavy mass only drove it closer to the ground. Returning to the 1990s crisis, engineers desperately stacked 600 tons of lead counterweights on the elevated north side. This temporarily halted the movement, but it was an ugly stopgap measure. This cross-section illustrates the ambitious 1995 plan to secure the foundation to bedrock. Engineers injected liquid nitrogen deep into the groundwater-soaked soil. The frozen groundwater swelled in volume, lifting the elevated north side and leveraging the heavy south side further down into the mud. The structure leaned even further. Calculations showed that if the weight distribution shifted by just 7% more, the stone would instantly shatter. The failure of the nitrogen plan left the team with no choice but to address the stability of the soil directly. The final rescue method, known as under-excavation, required removing material rather than adding it. First, the team harnessed the fragile midsection with massive steel cables to secure it from falling during the highly delicate procedure. This diagram shows thin diagonal guide drills inserted deep into the soil beneath the elevated north side. Slowly, they extracted tiny amounts of dirt. As the cavities collapsed, the massive stone base gently settled backward into the void. By carefully removing the dirt supporting the high side, we worked in harmony with the soil's physics instead of fighting the building's immense weight. The under-excavation successfully reduced the angle from a deadly 5.5 degrees down to a safe 3.97 degrees, effectively reversing centuries of sinking. They stopped there, leaving the lean intact. Completely straightening the monument would have destroyed Pisa's massive tourism economy. To ensure the soil density remains perfectly balanced going forward, they dug 3 underground wells on the north side to continuously drain away excess groundwater. Stabilizing the tower at 3.97 degrees ensured it would remain standing while preserving the specific lean that defines its history.